want to know too? Alright, let's study together.
Additive manufacturing, also known as 3D printing. It is process that creates physical objects from a digital design. An engineer designs the object using computer-aided design (CAD) software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source such as laser or electron beam then melts the first layer of 3D design. The platform is lowered and another layer of metal powder is spread across the platform. The layering and melting process is then repeated until the part is complete. The metallic powder is removed and physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditional matte parts.
Types of additive manufacturing.
First is material extrusion. This common additive manufacturing process uses polymer which are either extruded or drawn through a heat nozzle which is mounted on a movable arm. This will melt material layer by layer as the nozzle moves horizontally and the bed moves vertically. Second is wet photopolymerization. It uses a vat of liquid photosensitive polymer resin. This resin hardens on exposure to UV light. This property is used to build objects layer by layer. A vat filled with the liquid photopolymer resin is exposed to UV light in a controlled environment and geometry of the object to be printed is traced out. Third is powder bed fusion. PBF is an additive manufacturing technology which fuses powdered material to adequately create or build 3D objects. Other technologies which operate on this principle are selective laser sintering, SLS, electron beam melting, EBM, and elective heat sintering, SHS. Bed fusion process uses a laser or an electron beam to sinter, melt, and fuse the powder particle together, which is traced the cross-section of the object to be created. On completion of the first layer, the powder dispensing unit spread a new layer of powder onto the build platform and the printing continues for the next layer. This process continues till the complete object is built. Next is binder jetting. Binder jetting 3D printing technology is similar to material jetting, but it uses two materials in place of one. The two materials include a powder-based material and a binder material. Binder is usually liquid and is dispensed from printer head, which move in X and Y direction. Fifth is direct energy deposition, DED. Is used for 3D printing of metal and alloy. It can be used for polymer, glass, and ceramic, but is not popular use for those materials. In DED, a nozzle holds a material in a wire form, which is known as a feed, which moves across multiple axes, and an electron beam projector, which melts the feed as it moves across while tracing the object geometry. Next is material jetting. Material jetting process operates in a similar way a regular two-dimensional inkjet printed work. Material in the form of liquid droplet is dispensed from multiple printer heads similar to those in an inkjet printer. The material is photosensitive polymer which hardens on exposure to UV light, thereby building the part layer by layer. It is a multiple material technology which enables full color printing. Last is sheet lamination process include two types of manufacturing technique. Ultrasonic additive manufacturing, UAM, sheet or ribbon of metal are bound together using ultrasonic welding. After the welding, the part does not require any additional type of machining or removal of material. Different metals like aluminium, copper, steel, and titanium can be joined together, which allow for greater flexibility in strength requirement of the
Applications of additive manufacturing. Nowadays, 3D printing or additive manufacturing has been used in the manufacturing, medical, industrial, and social-cultural sectors. First, additive manufacturing in medical. The use of direct historical 3D printing therapy beginning in the mid-1990s with anatomical modeling for bone reconstructive design. For example, therapeutic tracheal splint for newborns and printer parts to reshape the face. Secondly, additive manufacturing in fashion. 3D printing are used also in the fashion. Fashion designers always do experiment with fashion using 3D printed dresses. For example, Nike use 3D printing for prototype. Thirdly, additive manufacturing in car, truck, and airplane. As we can see, they use production of unibody and fuselage and the design and production of powertrain. For example, Swedish supercar manufacturer that use 3D printed for the component. Next, additive manufacturing in field of cultural heritage. Many European and North American museums have purchased 3D printers and restart their lost relics. So now we can see that 3D printing will be a revolutionary force in manufacturing.
Hi, I'm SHAZREEN and today I'm going to talk about advantages of additive manufacturing. The first advantage of additive manufacturing is it reduces waste production. Additive manufacturing generates significantly less waste than traditional manufacturing method. The removed material is usually in form of kneading or shaving that cannot be reused and therefore it ends up waste. Instead of removing material, it adds material layer by layer so that what is required get used. If you see the picture below, it is an example of material waste. And also, the other advantage of additive manufacturing is rare shape making ability. Additive manufacturing is very attractive for unusual and complex component shape that can be difficult to manufacture using other process. Design software make it possible to create nearly any geometrical form. And lastly, manufacturing and assembly in one process. An additive manufacturing line can reduce multiple components at the time instead of creating individual parts and assembling them at a later point. An additive manufacture can be combine manufacturing and assembly into single process.
Like others manufacturing, additive manufacturing also have their disadvantages. Number 1, additive manufacturing slow build rates, as many printers lay down material at a speed of 1 to 5 cubic inches per hour. Depending on the part needed, others can be faster than additive manufacturing. Point number 2, additive manufacturing is a discontinuous production process. One part can only be printed one at a time to prevent economic scale. Additive manufacturing is poor mechanical properties. Bilayering and multiple interfaces can cause defect in the product. The next point is additive manufacturing high production costs. Sometimes parts can be made faster using techniques other than additive manufacturing, so the extra time can lead to higher costs. Last but not least, additive manufacturing requires post-processing. The surface finish and dimensional accuracy may be lower quality than other manufacturing methods. But with all the disadvantages of additive manufacturing, we still can't deny that nowadays additive manufacturing helps easier our job, especially in production factory. That's all from me. Thank you.